Hello everyone. In today's lecture, again we will continue the chapter 3. In previous lectures, we have completed details about aggregate. So in today's class, I am going to discuss about water. So concrete is produced by mixing binding material and inert material with water. So water also plays an important role in determining the quality or to find the quality of concrete. Also, the strength and durability of concrete is to a large extent determined by its water quality to cementitious material ratio. And next is there are also different functions of water in concrete, like the quantity of water in the mix plays a vital role on the strength of concrete. Some water which have adverse effect on hardened concrete sometimes may not be harmless or even beneficial during mixing. So, clear distinctions should be made between the effect on hardened concrete and the quality of mixing water. So, let us discuss the different quality of water for mixing and curing of concrete. So, generally we use drinking water for the preparation, that means for mixing, curing of concrete. This is to ensure that the water is reasonably free from such impurities as suspended solids, organic matter, dissolved salts, which may adversely affect the properties of concrete, especially the setting time, hardening, strength, durability of concrete. And the water shall be clean and shall not contain sugar, sewage, oils or any other organic substances. And alternatively, we can also test water in an approved laboratory for its use in preparing concrete or mortar. And the water quality for construction shall be tested or monitored regularly as it affects the overall strength of concrete. So for plain and reinforced cement concrete, permissible limits of solids are available. For example, we can say organic matter, it has permissible limit like 200 milligram per liter. If present, it may not create any harm to the properties of concrete, but more than this much, it adversely affects the properties of concrete. Similarly, inorganic matter 3000 milligram per liter, sulfates 500 milligram per liter, chlorides 1000 milligram per liter for RCC work and 2000 mg per liter for PCC work. Suspended matter 2000 mg per liter. So these are some permissible limits of some solid matters which are present in water. If they present within this limit, it's okay, no matter, but beyond this limit, they adversely affect the properties of concrete. Next is effects of deleterious materials of water in concrete, like deleterious substances like suspended particles. How it affect? Like if the mixing of water contains suspended particles more than 0.02% by weight of total water in concrete, then it affects all properties other than strength of concretes. Next is inorganic salt. Inorganic salt like zinc chloride, nitrate, sodium phosphate reduces strength, whereas sodium and potassium carbonates result very rapid setting of concrete. And the percentage of calcium chloride in water more than 1.5% of total weight of cement reduces rate of setting of concrete. Next is acids and alkalis. So the acid and alkalis basically present in industrial wastewater results in undesirable alkali aggregate reaction, giving cracks, or they may create different cracks on concrete surface. Next is algae. It is present in water, reduces bond. If they present in water, they reduces bond between cement and aggregate. So obviously, if bond is not strong, then strength and durability of concrete also decreases. Next is sugar content. So the sugar content in water between 0.05 to 0.15% by weight of water results in retarding setting time and create early strength of concrete. But more than 0.2% will give fast setting but reduces ultimate strength of concrete. Next is mineral oil. So mineral oil more than 8% reduces strength of concrete, and vegetable oil shows detrimental effects on concrete strength at its later stages. So with this, the second part, that means water part, completed here. Also one thing it is necessary for you to know that always we have to maintain the pH value of water within 6 to 8 for preparation of concrete. The last part is admixture. So first is what is admixture or what are admixtures? So these are artificial or natural materials added to the concrete besides cement, water, aggregates to improve certain property of concrete during casting or setting or service stages. So to improve the properties of the concrete required, it can be of two types like chemical and mineral. So chemical admixtures like air entrainers, water reducer, set retarder, accelerator, super plasticizer, these are some examples. And the chemical admixtures reduces the cost of construction, modify different properties of hardened concrete, and also ensure quality of concrete during mixing, transporting, placing, curing, and overcome certain emergencies during concrete operation. And the second is mineral admixture. This make mixtures more economical, reduce permeability, increase strength, and influence other concrete properties. And these mineral admixtures affect the nature of the hardened concrete through hydraulic or pozzolanic activity. And they can be used with Portland cement or blended cement either individually or in combinations. Next is different functions of admixtures like it improves workability of fresh concrete, improve durability by entrainment of air, reduce the water required, to accelerate setting and hardening and thus to produce high early strength, to add curing, to impart water repellent, waterproofing properties, to reduce bleeding, to reduce the evolution of heat, to impart color to concrete. So these are some functions or basic functions of admixtures. Next, let us discuss types of chemical admixtures. Already I have told, like accelerating, retarding, water reducing, air entraining, super plasticizing. So these are basic admixtures or chemical admixtures, basically or generally used. So let us discuss one by one. Like first is accelerating admixture. So these admixtures are used to reduce the initial setting time of concrete. That means they speed up the process of initial stage of hardening of concrete, so that they are also known as accelerator. So example are some silica fume, finely divided silica gel, calcium chloride, calcium formate. So these are some examples. Next is retarding admixture. This admixture slows down. It is the opposite of accelerating admixtures, and this admixture slows down the rate of hydration of cement in its initial stage and increase the initial setting time of concrete. And these are also known as retarders and are used especially in high temperature zones where concrete will set quickly. So some examples are gypsum, starch, cellulose products, common sugar, salt, acids, etc. Next is water reducing admixture. So these admixtures, as the name itself shows, defining that they are used to minimize the water demand in a concrete mix. And the workability is the important property of concrete, which is improved with the addition of water. But if water is added more than required, the strength and durability of properties of concrete gets affected. So this is the water reducing. These are also known as plasticizers, and these are classified into three types like plasticizers, mid-range plasticizers, super plasticizers, and the last one is air entering concrete admixture. These admixtures are one of the most important inventions in concrete technology. Their primary function is to increase the durability of concrete under freezing and thawing condition. And most used admixtures or some examples are Derex, Tipple, Benzol Shine, etc. And when these admixtures added to concrete mix, these admixtures will form millions of non or air bubbles throughout the mix and improves the properties of concrete. And next is super plasticizing admixtures, the last one. So it transforms stiff, low slump concrete into flowing, pourable, easily placed concrete. They can also improve workability, speed finishing, increase strength, conserve cement, and help reduce shrinkage and thermal cracking. So with this, chapter 3 is completed, and in next lecture we will start next chapter. This is chapter 4. So thank you.